Good morning, everyone. Thank you, Jose, for inviting me to yet another exciting edition of the TIS Summit. It's always been great being part of the previous editions as a way of learning and exchanging new ideas and perspectives. This time, however, I need to do this online and using this pre-recorded message. But I do see a great lineup of speakers today with some great ideas, solutions, and it's a sort of a representation of how far we have come along as a civilization as a whole in rising up to this challenge of climate change and sustainability. We're solving for it in different ways, in different disciplines, be it material science, energy, tech and AI, policy, and across industries, be it decarbonization of cement and steel, or how we consciously consume food and material, solving for electrification of transport or the green energy transition itself. It's very encouraging, therefore, to see how far we have come. So almost giving us this notion that if we stay the course, we'll ultimately get there in terms of collectively achieving the global targets of the whole of humanity. That said, I do think there's one fundamental aspect that I thought is missing, which I think is a necessary condition to sort of take all our efforts to the ultimate destination we are all trying to achieve as the whole of humanity. Now, what is that aspect? I call it the greatest coordination problem of our times, because what's something that we don't often always understand is the non-linearity of the problem, and therefore how we put together and collectively bring these solutions to effect. Exponential response is not solving for silos, but how each of our solutions are feeding into solutions of something else and collectively making it easy for a new solution to get created and exponentially adding value to all of us, where each of our net zeros is feeding into somebody else's net zero, and collectively it makes it easy for some more to get into this whole net zero wagon, and then collectively we achieve this exponential net zero effects. This cannot happen if you do this in silos. This needs coordination, and let me give you two quick examples of where I see a lack of coordination is sort of creating this stalemate or slow progress or even gridlocks, and an example of how we are actually addressing that through a better coordination. The first example is this whole electrification of mobility. We all believe that electrification is the way to go, which means everybody should buy EV vehicles, and the EV adoption has gone reasonably well, and therefore we are saying things will start moving fast. But today we have good number of charging point operators. In India, I think the number is 75, the last count, 75 different charging point operators. And we thought each of their efforts individually should have accelerated the EV adoption. But no. What we're discovering is some of this EV charging infrastructure is actually suffering from very low utilization. Some of the utilizations are under 10-15%. I'm talking about public EV charging, which means not enough people are using chargers, which means not enough people are comfortable yet with this notion that EV vehicles is a way to go. Now, if we were to solve for this using coordinated action, which we are trying to do in India, and some of my colleagues during the rest of the day will give you real examples of how we're solving. Now, we are trying to create this sort of a coordinated infrastructure digitally, wherein as an EV user, I can find any EV charger of any charging point operator without having to download these 75 different apps, but just using the comfort of the dashboard of my vehicle or an everyday app like WhatsApp or any of those big UP apps in India, and use that to seamlessly discover any EV charging in my neighborhood or in the place of my interest, and therefore reduce the marginal cost of discovery without downloading those 75 apps. And by that very unlock, we are seeing a huge coalition of EV charging companies. In fact, we have a whole alliance that got created of EV charging companies coming and saying, oh, this is great. You're solving for my discoverability problem, and therefore more discoverability and better asset utilization. And by having this coordinated effort of all these EV charging companies coming together on a common web and making it easy for the users to discover and find chargers without having to we operating like in parallel trenches in silos without talking to each other. But that's one example. Now, if I were to just extend that example a little further, by actually doing this, you're creating a larger coordination dividend for actually the EV OEMs. By creating this supply liquidity, this copious dense supply liquidity of EV charging, we are actually making the user ask, if this can happen at scale and it's EV charging are generally available everywhere and the ease of finding that is easy, why should I be investing in a long range battery? So which means I can probably live with a short range, and therefore my cost of the vehicle because of a short range battery is going to come down, which is actually good news for OEMs, because OEMs probably make more money selling cars and not batteries, so they can sell more cars. So this creates the next sort of a flywheel effect of more adoption. And if I were to push this a little further, this coordinated action between EV adoption and EV chargers, along with the OEMs creating coordination dividend for better financing services to happen into the space. You'll be able to offer usage-based, more targeted, low-risk, low-cost loans, be it to a charging company as a business or to the EV user. So reducing the overall risk and cost in this. If you don't do this, and this is extremely important when you have to contribute an exponential effort to solving climate action. If you don't achieve this and if you continue to operate in silos, we will be probably still languishing in very poor EV adoption and very poor utilization of EV chargers. So that's one example of why coordination becomes important as a way to accelerate and scale up our efforts in no time. The second example is about the rooftop solar adoption. It's a big talk now in the country, but let's imagine where everybody is adopting a rooftop solar, and sometimes the sun is abundantly available, sunlight, and therefore you're generating more electricity, more than you need, and you're trying to push it back into the grid. Now, what we don't know is that grids are underprepared to take that sort of energy pushback coming from the consumer, because the grid has been built over centuries to be this complex machine on the planet to push energy one way, and it takes time for them to accommodate sudden surge of supply going the other way and plan for it, because grid is a complex demand supply balance. There's no inherent storage in that design. So you're dealing with creating outages, gridlock in the grid because of excessive adoption of a green solution. And that's again a problem of coordination. Now, how do you manage this? Requires a coordination fabric where the grid has better observability, better forecastability, better controllability, so that one, it accelerates the adoption of green energy through rooftop solar, but also grid is able to sustain and withstand and actually double up that in effect. And that requires complex set of ecosystem players of solar installations, virtual power plant companies, and a whole lot of other technologies of have this synchronous adoption or some coordination with the energy companies and making them work as a. So we are talking about how do we enable peer-to-peer energy trading, where if the grid does not have to buy that excess energy, can somebody else buy that energy? From an economic standpoint, grid can offer green slots for pushback of energy, and there's more enablement of storage because there's more observability, and we are trying to create that coordination. These two examples sort of just as an indication of how this lack of coordination and the coordination dividend as a scenario is sort of the same situation or the movie that keeps repeating itself in every industry, be it food chain, be it climate resilient agriculture, be it about the whole climate data and reporting as a matter, or any other sector. And I thought I'll leave you with this thought about how, beyond what we are trying to solve as specialists, technologists, policymakers, governments, how we need to sort of collect all our efforts and create this coordination possibility. And that's where technology can do this coordination at scale with technologies like open protocols, like open networks, and that's some of the effort we've been doing. I would encourage you to also look at it and see how you can contribute to this form of solving as well, apart from whatever solves we have. Thank you so much.